In this video, we are going to configure DHCP on our router using the Cisco Secure Device Manager. So here's our good friend, the Router and Security Device Manager. We are on the Additional Tasks tab of the Configuration pane. So here is the DHCP folder. So we're going to click on DHCP, and it gives us an overview of the two items you can configure. You can configure DHCP pools, and you can configure DHCP bindings. First, you have to configure a pool before you can bind it to an interface. So we'll go into DHCP pools. There's nothing configured so far. It's a blank slate of a router. So we'll hit Add, and we'll go through all of these options here explaining what they are. The DHCP pool name is the name of the DHCP pool in the router configuration. The end user clients don't ever see this DHCP pool name. It's used just for reference inside the running configuration of the router. Now, if this were the router at the middle of a network where you had multiple subnets requesting DHCP from this device, you could obviously name each pool differently. And in fact, you'd have to name each pool differently so that you know exactly what addresses are in use in that pool. In this case, we'll name the pool Lab Pool. It wants to know the DHCP pool network. This is the IP network and subnet mask that you're going to hand addresses out from. In this case, our network on the inside is 10.10.1.0 with a subnet mask of 255.255.255.0. So that is the definition of the pool up here at the top. Now we're asked for the starting and ending IP. And I know you might be thinking, well, I've just given you the pool network and subnet mask. Can't you figure out what the starting and ending IP is? You could tell the router to hand out every IP address in that range, but you know there's going to be at least one IP address taken, which is the IP address of the router. There's probably other devices that have static IP assignments in this subnet for printers or workstations that have to be remotely accessible. Maybe you've got a couple of servers. And so within this DHCP pool network, you will only want to hand out a subset of the IP addresses. In this case, we will hand out addresses starting with 10.10.1.50, and we will end with 10.10.1.200. Next, we'll look at the lease length. Now, the default is user-defined to expire after 1 day. What the DHCP lease allows you to do is tell the workstations you have to come back every X number of days or X number of hours or minutes, and you have to request to keep your IP address. And assuming that no one else has requested that address at the exact same moment, you'll probably get to keep your lease. It's much like leasing a car or leasing a building. Every so often you go back to the leaseholder and say, hey, I'd like to continue living here. Can I sign another lease for another year with you? And assuming that no one else wants to occupy that building, you'll pretty much have the lease forever. What this allows you to do with DHCP also is define a period of time in which the IP address will be released back into the pool for reassignment. Let's say you're running a coffee shop and it has a wireless hotspot in it. Well, obviously you would not set the lease length to never expire. You wouldn't do that even on a corporate network, but definitely not in a coffee shop where you've got hundreds of people a day coming in and out. You'd set the lease down to 30 minutes or an hour. So essentially what that lets your router do is if no one comes and asks for this IP address within an hour, then that IP address is available for reassignment to the next client that asks for it. It allows you to turn over your IP addresses fairly quickly. For most corporate networks, the default of 1 day is sufficient. However, if you're running a wireless hotspot or a guest network, you'll want to tune that down to 30 minutes or 1 hour, just so you don't run out of IP addresses on your guest network because you happen to have a whole bunch of people come in very quickly. Next, you have some basic DHCP options for DNS servers and WIN servers, domain names, and default routers. All of these are optional. You can import them from a higher level DHCP server. For example, if this is an actual internet router and it's set to DHCP this information from your internet provider, then you can just pass along the DNS server and the default router, so on and so forth. If you leave the default router blank, it considers itself to be the default router. In this case, we will put in one DNS server of 192.168.1.254, which is my internal firewall's address, because it's also running a DNS relay, and we'll put those requests out to the internet. I'm not running WINs on my lab network. We'll give it a domain name of lab.local, and we'll leave the default router blank because we're just going to use ourself as the default router. Now, where you would want to actually specify a default router that may be different from your local IP address is going back to that situation where you have a centralized DHCP server. Obviously, if this pool is for a subnet that's on the other side of a WAN link, you'll want to specify that the default router is the router that's on the other side of that WAN link and not you, because you have to be able to reach your default router. It's kind of the way routing works. So now that we've filled in all of the commands and options that make sense for this particular DHCP pool, we'll hit OK. And SDM ever so graciously delivers the commands to the router. So we'll hit OK. And now we have a pool up here, and we see all of the parameters that's being pushed out to our DHCP clients. We'll pick this up in the next video where we bind this to an interface and crank up one of these VirtualBox machines and make sure we get an IP address that's in the correct range.